Hi everyone, Victor here again, and in today's lesson, we're going to be looking at how to control the scheduling of pods in the nodes, apparently into the worker nodes. Like we have discussed in one of our previous lessons, I guess the first chapter, we learned that the scheduler is the service that is responsible for scheduling which worker nodes a pod will be created on. The scheduler looks at the resources on each worker node, RAM, CPU, cores, etc., and then schedules the pods in a way that loads will be balanced across all the worker nodes in the cluster, and it does this by default. However, in some cases, you might not want the scheduler to automatically schedule the pods across the nodes in a cluster due to the kind of design you want in your environment. For instance, some nodes may have a higher computing power than the others, and you might want some of the applications that requires high computing be created in those nodes. Hence, you will want to schedule those application pods on those nodes. Another scenario is if you have to leverage on packages or binaries on particular nodes or local storage of some particular nodes that the pods will use, you might consider scheduling the application pods on those particular nodes. And another reason could be that you might want to separate your production pod from the development pod. So there could be a lot of reasons why you would want to control the scheduling of pods on a particular node or particular set of nodes. And scheduling a pod to a node can be done using labels. We already talked about labels and selectors in one of our previous lessons, so this shouldn't be a problem. Labels can be used to schedule pods to a node, and there are basically three ways to schedule pods to a node using labels. One, we can use the node name field. Secondly, we can use the node selector field. And the third one is that we can use affinity and anti-affinity constraints. In this lesson, we'll look at using node name and node selector fields only. We will look at the affinity and the anti-affinity constraints in other lessons. So let's talk about using the node name field. By default, Kubernetes or OpenShift recognizes some standard definitions in the cluster and assigns them as labels. For example, the host name. Kubernetes assigns the host name as a label to your node. Kubernetes also uses some other attributes of the node, for example, CPU architecture, to assign labels to the nodes. To schedule a pod to a node, you can use the node name field in the pod spec section in your YAML manifest file to schedule a pod to that particular node by using the host name of that node just as we have it here. Say worker node 1, worker node 2, and worker node 3 have host names such as WK1, WK2, and WK3. You can schedule a pod to WK1 by using the node name field. Using the node name field to schedule a pod has its own drawbacks because node names are unique, meaning that pods can only be scheduled on just one particular worker node amongst other worker nodes in the cluster. However, the good news is that you can add additional labels or manually assign custom labels to your nodes. For example, if we have worker node 1, worker node 2, and worker node 3, you can assign labels to these worker nodes using the key value pair. Say for worker node 1 and worker node 2, you can assign a label such as WK node equals front end, and you can use the node selector field in the pod section of the YAML manifest file to schedule pods for the nodes that have the label worker node equals front end. This means that pods would not have to be restricted to just one particular node, and if it is just one pod, the scheduler will schedule the pods on any of the node with the label. This method is very common and of course a better approach compared to using the node name field because you can assign more than one label to nodes and maneuver the scheduling of pods across the node as you want. You might also decide not to use the YAML manifest file. You can also use ad hoc to add labels to nodes. And as we go on in this course, we're going to look at how to do both. So having understood this, let's get to action and let's see the step-by-step guide of how to perform the scheduling of pods in Kubernetes or OpenShift cluster.